In previous videos, we have looked at using the sine ratio, which is the opposite leg over the length of the hypotenuse, the cosine ratio, which is the length of the adjacent leg over the hypotenuse, to find the lengths of missing sides of right triangles. In this particular video, we're going to focus on tangent, the length of the opposite side over the length of the adjacent side, to find the length of the missing side of a right triangle. So let's take a look at an example. I always circle the angle that I'm working with so that I can identify the sides of my triangle. And as usual, I find where my right angle is so that I can find the side that is opposite that angle and identify my hypotenuse. I do that so that I don't confuse it as being an adjacent side. Opposite of the 30-degree angle will be my opposite side, and that leaves the third side then to be the adjacent side, in this case the A that we're going to be looking for. So we can write that the tangent of 30 degrees is going to equal the length of the opposite side, which is 20, over the adjacent side, which is A. And as I've mentioned before, we can write this as a proportion, write the tangent of 30 over 1, so that we can use the cross multiply or the butterfly method to write this in a way so that we don't have any fractions, and it makes it easier for some of you to see how to solve this. So we end up with A times tangent of 30 is equal to 1 times 20. Well, we know that 1 times 20 is just going to be 20, so let's just write 20 there. So that when we want to solve for A, when we want to isolate A, what we're going to do then is divide both sides of the equation by tangent of 30. And more specifically, tangent of 30 degrees. Now I'm going to go to the Desmos Scientific Calculator. And I want to make sure the calculator is in degree mode, the DEG. And let's just verify what we said we were going to do, is going to be 20 divided by tangent of 30. So if we go back to that calculator, 20 divided by, notice it makes it a fraction for us, tangent of 30, and we can close the parentheses. And it's already put an answer there, but I'm going to go ahead and press the enter because we're done with the operation that we need. And rounded to the nearest tenth is 34.6. So when we go back, we can say that A is approximately 34.6, and we have units on this triangle, so we can say 34.6 centimeters. On our next triangle, we have a 52-degree angle. The hypotenuse is side XY. Opposite of the 52-degree angle is the X that we're going to be looking for, which means the 8.5 is the adjacent side. So we can write that tangent of 52 degrees is going to equal X over 8.5. Now we wouldn't necessarily have to write this as a proportion. You could ask yourself, well, how can I isolate the X? How can I undo the divide by 8.5? And to do that, we can multiply both sides by 8.5. The 8.5 will cancel on the right side, and we're left with the mathematics that we'll need to do to solve for X. So we can go to our Desmos calculator again, and we had 8.5 times tangent, and I just need to double check the measure of that angle, 52 degrees. 52. Oops. As you can see, my angle did not end up in the parentheses, so I need to back up, put my cursor inside the parentheses, 52, and enter. And to the nearest tenth, because the 8 is followed by a 7, which is greater than 5, this becomes 10.9. So when we go back to our problem, 10.9 is approximately the length of x. And this is how we can use the tangent ratio to find the length of missing sides of right triangles.